All right, example 4, we have a pilot must descend 2,000 feet over a distance of 12,000 feet to land smoothly on a runway. What is the plane's angle of descent? Well, an angle of descent is going to be an angle of depression. So descent and depression, we're talking about the same thing. All right, so we've got a pilot flying something, maybe a plane, so whatever that might look like. Well, not really that, but just pretend that's a plane. Because the pilot has to descend 2,000 feet, that tells you that's how high up the plane is. So the plane is at a height of 2,000 feet. Now, it's going to go from 2,000 feet to 0 feet, but it can't do it instantly. You go straight down, that's not good. So it's going to do this over a distance of 12,000 feet. So we're 2,000 feet up in the air, and we've got 12,000 feet until we need to be on the ground. So they're going to descend like this, slowly, 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 till they are landing safely. So it says, here's our right triangle, so we can see there's the right triangle we have in all these. What is the plane's angle of descent or angle of depression? So the only thing we have to remember about that is these angles of depression and elevation always start with a horizontal line. So the plane is up here, I have to draw in a horizontal line, okay? And then the angle of depression is from the ceiling down, so from here down, this is what we have to find. So that's our theta, our missing angle. Well, a couple examples ago, we saw this where we can go back to our geometry knowledge and say, oh, we've got parallel lines, a transversal cutting through, which means alternate interior angles would have this be the same measure. So these two angles have the same measure, so let's find the one that's inside the triangle, and that will help us with the one that is the actual angle of depression. All right, so we focus on the angle inside our triangle, label our three sides accordingly. You've got your opposite side, which is across the triangle, the hypotenuse, which is across from the 90 degrees, and the adjacent side, which is next to it. Because we don't know the hypotenuse, we're going to focus on the opposite side and the adjacent side. So you've got SOHCAHTOA, which one uses the opposite and the adjacent, and it is going to be our tangent. So we set up our little equation. We say the tangent of theta, which we don't know, is equal to the opposite side, 2,000, over the adjacent side, which is 12,000. So here we are trying to find an angle measure again. When you're trying to find the angle measure, you bring in those inverse functions. So we're going to do inverse tan of that 2,000 over 12,000. Then you go to your calculator, you have to do second tangent, and then you just type in 2,000 divided by 12,000 inside those parentheses. And we get our angle measure equal to I'm going to round to the nearest tenth, so 9.5 degrees. And that makes sense that it would be such a small angle measure, because think about it, if you're up here on the plane, and if the angle of depression is really big, like let's say all the way down to here, you're basically nose diving into the ground. So you have to have a really small angle of depression so that you can, my picture's not accurate, it would look smaller than this. So you can slowly, over 12,000 feet, finally get down safely on ground.